All right. As Eric said, I'm Evan, Android developer at WillowTree. I've been doing Android for a few years. And so I saw a blog post a while ago on the Mobile Vision API and Play Services. So I thought it'd be cool to dig into that. And I wanted to share my learnings and how you can jump into Mobile Vision API and Play Services. So Mobile Vision is a cool thing, but I'm gonna step back and talk about computer vision real quickly. And so there's this huge academic definition from Wikipedia, but essentially computer vision is an entire field where you want to allow a computer to kind of see the world around them and sense it so that the computer is able to take certain action. So in the case of self-driving cars, you want it to be able to see and ID pedestrians, buses, emergency vehicles, cyclists, so that the car can operate in that environment without causing any damage or harm to people. And case goes all the way up to helping, in the case here, helping killer robots ID people who may be a potential match for a clothing theft. And so the top image is actually from NVIDIA. I think sometime last year, they have a self-driving car hardware platform, and that graphic is from that. And this is from Terminator 2 in the opening scene in the bar where he's identifying people and their sizes to see if the clothes will be a fit for him. So going to how it's incorporated in Play Services. So the API in Play Services allows your app to identify faces and barcodes in video and images. And this was introduced in Play Services 7.8. There's an entire blog post on this announcement. It was also announced with like other APIs like nearby messages. And there's a pretty good video that is done by Magnus. And he goes through several use cases on what you would use the face and barcode API for. And because it's in Play Services, it's available on Android 2.3 and above. So like, that's a ton of devices. So I'm gonna jump into a couple of concepts and definitions and then jump into some code real quickly. And so here, next slide. So a few concepts here. One thing to say up front is the API doesn't do facial recognition, and that differs from face tracking in that facial recognition can identify that my face is uniquely me. So for example, if I'm in Google Photos, Google will go through your photos and identify each individual face, and that face essentially belongs to a unique entity. Face tracking is essentially just tracking the face, and that is the same face across multiple photos or video, but not uniquely identifying that face as somebody. The API does face tracking and not facial recognition. And then the last two definitions are landmark, which is a point of interest on a face, so eyes, nose, mouth, ears, cheeks, chin, etc. And then classification is going to be kind of what attributes would you use to describe that face? So is the face smiling? Are the eyes closed? Is the face tilted forward or backward, left or right? So that's classification. So jumping directly into code, incorporating the Mobile Vision API from Play Services is essentially 2 or 3 steps. One is, as with all Play Services things, you need to define your compile statement, and you're going to stick that in your app Gradle file. And this says to bring in all the dependencies required for Google Play Services. Next, you need to declare the version of Play Services that you're using. And then finally, which is probably an important piece here, is the computation for recognizing faces and barcodes happens in a native library. That native library is not included in the APK when you build it and install on your device or download it from the Play Store. So what happens is you define which library you need by specifying either face or barcode or face, comma, barcode. And when the user goes to use your app and use the features that require barcode or face detection, that binary will be downloaded and installed on your device. Any questions so far? I feel like I'm flying through this. All right. So the first example we're actually going to go through is detecting faces in photographs. So this is a case where you have a photo editor and maybe you want to make it easier for the user to click on a face and apply certain filters. The next few steps in how is a framework on how you get that done. So very first thing you do is you build a face detector. The face detector is kind of the meat and potatoes of the API. Use the face detector.builder. You configure a face detector and then you build it. So in this example, I'm turning off face tracking explicitly. Face tracking by default is set to true, but for photographs, we don't need it because we only have a single photograph in this example. So I'm turning it off. And then I am detecting all landmarks. So you can detect all landmarks or no landmarks. That's configured here, and then I'm building my face detector. Next thing I do is I'm going to take my bitmap, which has my image data in it. So it could be a photo of my family, could be a photo of friends. I'm going to wrap that in a frame and then pass that frame to my face detector. And the face detector actually will give you a sparse array of faces back that were detected in that frame or that image. And so it's that simple. Let's see. So I have an example of that. Can I do this smoothly? All right. Okay. So I should point out that the documentation of the API, there are tons of code samples. And so this specific code sample is essentially is a single static image. And did I install it on this one? Face tracker, barcode reader. No, so let me do that real quick. So this is for the video. I can't just show this because this probably helps with the next one. All right, so face tracker is essentially doing is doing face detection but on video. And so here I have a couple characters of The Walking Dead. And the only thing it's doing is it's starting the camera, drawing the camera preview to a surface view, and then over that is a graphic overlay, which is responsible for drawing your squares here. And so this is using the face detection to detect faces in this video and also detect landmarks. So it's kind of small. You might not be able to see it. Actually, let me see if I can just do this. All right. But the text actually are values. And so not only can it detect noses, eyes, mouth, cheeks, and all that, but it can give you probabilities on whether or not that face is smiling, whether or not the left eye or right eye are open or closed. And so that is that. Any questions on that? Yes.
Is it a very limited set of landmarks that it's able to get?
Yes, so I can actually show. Here we go. All right. So this sparse array of faces are essentially an array of face objects. And a face object is essentially a collection of properties for a face that was detected. So Euler, Y, and Z are going to be the tilt of the head of the face forward, backwards, left, and right. The height and width of the face as it relates to the bitmap or the video that it was in. An ID is just an enumeration for that face. Left and right eye, open probability and smiling probability. And then each face, you have a list of landmarks. And so these are the types of landmarks that you can actually have detected by the API. So left, right, bottom mouth, which is cool. Left, right cheek, left, right ear, left, right ear tip, left, right eye, and the base of your nose. And so when you get a face from the API, it will give you all those properties. It will give you those properties back if it can detect all those landmarks, of course. All right. Make sure I covered everything. Cool. All right, so now this is the pipeline for tracking faces in video. Cool. All right, so tracking faces in video is a bit more complicated because instead of doing the face detection on a static photograph that you can simply hand to an API, you have to set up all the infrastructure to take video from a camera and pass that all the way through to a face detector. And so that's done here. And so starting at the very right side or your left, we have a camera API which will pass you image data every 30 or so frames per second. That is passed through a camera source, and a camera source is the mobile vision API's object for interacting with the camera and passing the image data from the camera to a face detector. The camera source also will pass the kind of preview to a surface view so that the user can see what the camera's looking at. So in case so the example I just showed, you saw the live video feed, that's all being handled by the camera source. Face detector is again kind of the main object here. It's going to analyze the camera video and give you faces back. This is where things begin to differ. So the face detector will recognize faces and then hand off all that data to a processor. And a processor describes the behavior that should occur when a detection is encountered. So in API, you have multiple processors. Processor you can use is largest face is going to be the largest face processor. And that simply will give you a face, give you the largest face in a particular kind of video. And the second processor is a multiprocessor, which will give you every face in a frame of video back to you. Each processor will use a graphic face tracker factory to generate a tracker, which corresponds to a detected face. And then from that, you can get a face out of that and then draw that onto your overlay. Or if you wanted to use the data for other purposes, you can as well. And so how to set all that up is kind of straightforward, more or less. So in the particular face tracker example, the developer who built this example created a camera source preview, which wraps a surface view, and it also handles starting the camera for you. So that's used here. And then the graphic overlay, which enclosed in your camera source preview, its only job is to draw the squares and details over the surface view so that you can physically see or visually see the faces and details and such. And so set this up in XML. This is going to be my activity, for example. And then in code, you just get a handle through preview. Next step is, of course, go to your face detector. Here I'm setting a classification. I want to detect all classifications. Since face tracking is enabled by default, I don't have to do that here. So I build it. Next step, my face detector, I pass in a particular processor I want to use for this detector. So in this case, I'm using a multiprocessor with a graphic face tracker factory that will give me a face, every face encountered in that video. Then finally, I build a camera source, which is kind of the glue between the mobile vision stuff and the device's camera. There are several methods here for setting the requested preview size, whether or not you want to enable autofocus, whether or not you want to use the front and rear facing camera, setting the requested frames per second, and other details like you can set a threshold on If their face is too small in the picture, ignore it. So for the requested preview size and requested frames per second, so every camera or more or less every device has a predefined set of camera resolutions that camera can display at. The API, as developers, we can say, I want this preview size, and it's the API is going to say, I'll try my best to give you the requested preview size. So for example, if I ask something crazy up here like 1222 by 1333, of course, that's probably not a standard resolution for a device camera, but the API will find an adequate resolution to kind of meet my requirements. And then in the example here, it's just a matter of you take a camera source, the face overlay, which is the graphic face overlay, which shows these faces, pass that to your camera source preview and start. And so that was what you saw in this example here, where you had, it started and now it's doing face detection in real time. There are, let's see. And so let me, so the example I was going to show earlier was doing the landmark detection in, whoops, there we go. Doing landmark detection on photographs. So this particular example embeds a single photograph and runs a face detector over it. As you can see, it identifies left, right eyes, cheeks, nose, the nose base, left, right, and bottom of the mouth. So all that's being done on a device. And so then you think about what kind of cool things can you do with this. I give the example of you have a photo editor, you want to make it easy for a user to edit faces, so detect them for the user and allow them to click on them to change skin tone, shape, etc. So what actually got me into this project is I wanted to build an app for, kind of a silly app to just replace your face with somebody else's. And so it's super crude, but I got far enough and it made me laugh. So I'm going to just show this real quickly. It's based on the face tracker app. I kind of reused the camera source preview and a graphic overlay to do this. But so the point here is you can replace the faces here with faces of crying Michael Jordan. And so that was my inspiration behind this project. But essentially, just replaces that square with a drawable of Michael Jordan. This could be anybody, it could be animal, etc. So. All right. So that's actually all I had. So all the links I used, or resources, are up here on the slide, linked to the API themselves. The source code for the app I just showed and all the apps I showed actually are in these two GitHub repositories. And then the Android developer blog post that has a video where Magnix goes through different use cases for this API is in that blog post as well. Yes, that was any questions?
Do you know if there's a limit to how many faces it can recognize in a single photo or video?
That's a good idea. All right. That's a very good question. So what I did earlier is, let me try to get my cursor back. So I just did a Google image search, and I wanted to do, to open this app again. I'm gonna guess it's probably dependent on the device, but I don't know for sure. Let me see. All right, so I just essentially did an image search for faces earlier, and it can do more than I would need, I guess. So that's all done in real time, which is cool.
Yeah.
I would imagine if I plug up a Nexus, a Galaxy Nexus, or an older device, I would imagine it wouldn't be able to detect as many faces, or the frame rate of the preview would be a lot lower as well. Yeah.
Work on caricatures or cartoon-like faces.
No.
Can it detect cartoon-like faces or caricatures or only human?
If the cartoon face has, I would say if the cartoon face resembles a human face, it would. So if I go to smileys, I wonder if this will work here actually.
Yes, you could test it.
Yeah. So here it does not actually detects the faces in the crowd. No noses. Yeah. Let me see. Cartoon. So yeah, a few of them. Yeah.
And that's all on the device.
Yeah, all in a native library that's downloaded.
So if you're in airplane mode
Mhm.
and you start the app, does it just not work?
It should work if it's the first time you start the app and the library hasn't been downloaded, I would imagine it won't work. But if I stick the device in airplane mode, everything is local to the device, so it should work already, or it should work regardless. So yeah.
Is there no granularity between all landmarks and no link?
Those are the only two options right now. Yeah, I thought there would be more. So essentially, I would imagine they're going to add more because enough. I guess if they weren't, they'd probably just make it this true false type of thing.
Did you run into anything that was like a gotcha?
So the gotcha was not kind of related. It's kind of related to the API, but the requested preview size. Finding a preview size to let my UI around and have it correctly fit was kind of annoying because I would specify resolution that would fit exactly on my device, but then I would get either a lower resolution or a higher one because that mode wasn't supported. So yeah.
The picture is highly pixelated, will it still work? Or
Now I can do it. Let me see. I'm gonna highly pixelate this. Let's all right, I'm gonna do some GIMP things real quickly. Oh my gosh. All right, let me drag this over here and canvas scale image. All right, so have a reasonably pixelated image here. All right, so that's not pixelated enough. So this image here is kind of pixelated, so I will lower that resolution even more to see how low I can go. At this point, I would. Oh, 3, okay. Which is, it's kind of weird, actually. Yeah, so.
I'm surprised it's not picking up more false positive.
Yeah.
Like if you just showed her here, it seems like it should be picking up like anywhere there's 2 dots in it.
Nose, right. Yeah, so does that answer your question?
Yes.
Cool.
It does seem like they're showing that they're happier also.
It does, yeah.
Yeah.
Right. So that is, if there aren't any more questions, I'll end it here. Cool. I will post a link to the PowerPoint in the plus on the plus event page. Cool.